guys, let's try this and see how it works. We're going to focus on chapter 4.1, discrete random variables. Now remember, we talked about discrete variables before. Those are the ones that are numerical and they can be counted like 1, 2, 3, as opposed to the continuous like height or time where you can count in milliseconds or, 1/20th of an inch. So discrete can be counted, and don't get confused with the word random. I know we talked about random sampling where you just kind of randomly pick something. We're not randomly picking variables. It is a particular type of variables that we're going to describe below. So let's scroll down to chapter 4.1 and start putting in some definitions here. We have, random variable that describes the outcomes of some statistical experiment in words. Okay, so this would just be, how many heads do you get when you flip a coin twice? How many times does 3 show up if you flip a dice, 4 times? So the values of these random variables can vary, depends on how many times you repeat the experiment. And they also use this capital letter X to denote the listing of the random variable. So if it says it is a discrete random variable, that means that it has a finite or countable number of values, so we can actually list them. So we can list all possible number of outcomes. Okay. So just to help out in our little note below here in blue, if X is a random variable, then capital X there is written in words, where little x is a number. In other words, how many times something can show up. So let's look at 4.1. This will give us kind of an example. So it says let capital X, in other words, the random variable X, represent the number of heads when tossing 3 fair coins. So think of it as like tossing them in a row. The first one, second one, and third one. So capital S here with all of those in brackets shows us the sample space, which we've done before. But the little guy below here with the little x, these are all possible number of heads when tossing 3 coins. Right? We can either get no heads, 1 head, 2 heads, or 3 heads. So let's think about this example here for a second. Whenever we have the discrete random variables, we'll call them x sub I because we don't know which one we're looking at. Let's list all the ones for those 3, flipping those 3 coins, and how many heads we can get. For each of those, we can also list the probability of each of those events occurring. Okay, so notice back up here in S, okay, this guy right here, if we were to count all the different possibilities, there's a total of 8, okay, 8 ways that we can toss those 3 coins. Well, of those 8, how many of them have, remember it's the number of heads, how many of them have no heads? Only the first one, the tails, tails, tails. So 1 out of the 8 has no heads. Then we look to see how many of them have exactly 1 head. So here they are over here. That one has 1, that one has 1, that one has 1. So we've got 3 out of 8. Then we look for exactly 2 heads. This one, and this one have exactly 2 heads. So there's 3 out of the 8. And then the one that has all 3 is down here at the end. And that's only 1 of those out of the 8. So we can actually list all of the possible outcomes, the little x, and the probability of each of those occurring. So now we're going to work with what's called probability distribution. And guess what? I'm going to scroll up. What we just did over here is a probability distribution. Yeah. It provides all possible values of the random variable x and their corresponding probabilities. Now, we've worked with distributions before. They could be a table, they could be a graph, or some mathematical formula. But generally, when we're dealing with probability distribution, we normally see them in tables. So let's think about these probability distributions. There are two characteristics that are very common. One of them is that, very common, that are necessary actually, is that the sum of all the probabilities has to equal 1. Okay, so remember, we're listing all possible outcomes. So if those are the only possible outcomes, then one of those has to occur. So it should include all 100% of our possibilities. So if the sigma kind of throws you off, just write yourself a note. Adding of the probabilities should equal 1 or 100%. So for the second one, though, remember all probabilities are between 0 and 1. The only difference is our probability is still between 0 and 1. But you're never going to have one of the possibilities as a 0. Remember, we only list possible outcomes. So we're not going to list any impossible outcomes. So we don't have the or equals to sign with a 0. So taking a look at these three probability distributions, only one of them is a probability distribution. So if you want to pause the video and try to see if you can guess which one it is and determine why the other ones are not, go ahead. But I'll tell you right now, if we add up those probabilities, I think we get like 0.97, and that doesn't equal 1. So this guy's not a probability distribution. And you could probably tell what's wrong with B. Remember, we have to be between 0 and 1, so that negative ruins it for us. You can't have a negative chance of something occurring. I mean, if it can occur, it's just 0 chance. But all of these add up to 1 or 100%. So that is our probability distribution. So let's take a look at example 4.3. We have this table below that shows the probability distribution for the random variable x. And again, here it says x represents the number of movies streamed on Netflix each month. And that may have increased since this example was written, but you never know. So they're asking us two questions. The first one is, what is the probability of streaming at least 3 movies each month? So when you're looking at the word at least 3, is 3 included? 3 is at least 3, and then 4 is at least 3, 5 is at least 3, so we're going up. So we want the probability that our x, our outcome value, is greater than or equal to 3. So please get into the habit of writing those notations as well. And so we can just look at those probabilities and add them up. We don't have to worry about ands and ors and conditionals. This is kind of nice with the distribution. We just go, okay, we want all 3 of those. So 10 plus 0.03 plus 0.01, and we get 0.14 or 14%. Then the next question asks, what's the probability of streaming less than 3 movies? Well, with this one, just strictly less than, 3 is not included. So we want our x value to be less than 3, which includes everybody else, 0, 1, and 2. Well, noticing that those are all of our 100%, we can consider these two events here to be complements. So if the top one is 0.14, everything else that's left over is going to be our 0.86 or 86%. Now, we could still add it up. we can still add the 0.00 or 0.06 plus 0.58 plus 0.22. That would still give us the 0.86. So we're okay with that. Okay, and that is it for section 4.1.